Morning all, Shed Guy here, and we're looking at the tailstock on the Smart and Brown lathe. Bought some stuff from a guy called Ray. Knew about the lathe. I said, Ray, what's this bit for? He says, oh, that's for the dipstick. I'm going to make the part. He sent me a picture which was really helpful with some dimensions on. I looked on the parts diagram from Smart and Brown. The drawing has this part on, which is L4138. I redrew Ray's picture. I'm going to make that part, but so you're looking down on the top of the main casting. This is the little hole which the dipstick thing sits in. No idea. I've filled it with brake fluid. It's sat there for a while. It's going nowhere. I can't see any holes. I've inspected for them. This is a decent bit of air pressure now, so I'm going to, put pressure on there. Now what happened? The brake fluid is in there. If I let this go, it's going to go, everywhere. So that's not a through hole. So I'm going to try and run through a sort of servicing, put back together type video. At the hand wheel end, there's a machine surface concentric with the bore and the hole pattern. I have once seen a rapid drill attachment that fitted on the end of here, so you don't have to wind it in to drill, you can just pull it and go. The body's been bored or reamed or whatever to 1.25 inches. There's an anti-rotation here which this little slug locates into, with a couple of 4BA cap heads, which are going to usually be covered on here with just filler and painted over. So that anti-rotation key, it's 1.5 inches long. It's got a rounded end. Square end goes to the end of the tailstock, round end towards the nose of it. Alright, so I've got my finger down the hole. It's an orange Allen key, so it's imperial. So the anti-rotation key is in. You're looking straight down at the nose of it. The nose has been tapped out with 6BA countersunk machine screws. There's a wiper on there and a plated brass cover. So this is the underside of the casting, and this mates to... So the base of the main casting rides on this bottom plate. It can move side to side so you can offset the tailstock, and you've got 2 screws which rive against a fitted block. The fitted block is about 1/625 by 750. It's held on with I think 3/16 BSFs and a 3/16 dowel. So I'll put that back on. And as it goes back together, I'm going to give it a bit of ACF 50 and copper slip. So there you go, that little block's on good and snug now. Actually, it's precision fit, that took a bit of doing. So in order to move the main casting side to side, these are 5/16 UNC screws, which just work on those two faces opposing each other. I think these screws have been potentially mucked about with. On my other machine, my good machine, the ends of the screws sit in about 3/4 of an inch and 1/2 an inch. So 3/4 of an inch on one side and 1/2 an inch on the other side. Well, these are just miles out. So anyway, I pulled some spare screws. Spares department, of course, is another tailstock from eBay. Wouldn't you know it? There's a big score across the top. It could be just that that was where the casting came out. The handle got whacked out and replaced and then put in with a cap head. The quill lock there's got a big snot of weld on it. So all in all, it's a bit of a sorry job, but it's a fixer. Anyway, just before we put those spares in, we'll measure up. So 1.6 there inches long. Say 2 1/4. This block's not central, it's 2 1/2 inches on that side, it's 2 1/4 inches on this side, 2 1/2 inches on the tailstock locking side, the back side. So I'm putting the long screw on the back side and the short screw on the front side. And when they're in and adjusted up, that's roughly where they sit. So long screw back side, short screw front side. Right, next up there's a cam that goes in here, and when it's on cam, pulls down onto your locking plate and locks this underneath. So what I've just done, I've tried that in the hole here. It goes round quite nicely, feels good. But as soon as I get to the far end, it's jamming. So I've just mounted this in my lathe. It sits in a 11/16 collet, held it up tight. This end's running about 25 thou off. This end's running perfect, this end's running off. You know, evidence of tough life. There's the old handle broken off in there, and it's been hacked into, and another screw coming in from a more jaunty angle. And I've just tried to unscrew this handle out of this one, and of course no joy. So what I'm going to do is measure this. Right, well, this one's running just under 20 thou. This is probably the better. Both of these camshafts have got a little stop on them where that grub screw engages. On both of them, that little corner there was raised up and fouled inside the bore. So I just took a diamond file and just took those off as well. Alright, so we've been to the lathe, cleaned up the end. I drilled out the old handle. It's been wallowed off before, and I just thought, right, just redo the whole thing. I can run a nut up underneath if I need to. So there you go. Handle goes in. 5/16 width, and I'm not worried if it's a bit of a short handle, because people keep braying on these and jigging them up. It's got a 750 hole. It's been made from 1.25 inches. The width across the flats is just under 900. There you go, across the length there, 1.185. And the overall length, 2,800. So the length of the turn part is 1.640. Alright, so I am actually looking at the destructions as I'm going, the original plans, and it actually shows that this screw goes this way in, so that when it's been set correctly, you can't over tighten on this cap head and land up bending that bar. It's impossible to over tighten it because you'd hit the stop. Alright, so there's your little grub screw. It's a 3/16 BSF, just about 1/2 inch long. So then, in action, it's going to be held together with a 1/2 inch BSF cap head. Right, so before we start putting the quill back in, what we're going to do is just put the quill lock on. So there's your quill lock sitting nicely. So we can start looking next at the quill. This is the general arrangement. You've got the main quill. There's a thread inside here, big Acme thread. It's actually got a section here that can be adjusted via those little lugs there. There's a little screw that captures that, so you can sort out the backlash. That bronze section's internally and externally threaded, and you can just turn it either way you want. So the drive spindle's a left-hand Acme thread, no idea what size. I've got a thrust washer. This boss goes at the tail end of the tailstock. It's got an oil light bushing in there. Then you have another thrust washer. It's got a keyed shank. Put the key in. And then tension it with a nut. On the outside of the tailstock hand wheel, there's a satin aluminium inch graduated ring. For some reason this has been braided around on the end. Obviously, I don't know, drill got stuck. They got my finger stuck. Someone's whacked it. So I'm going to redress that, redress the nose. So I've run the quill through the lathe in the Crawford collet. The collet gripped it to about this length. 1.5 inch, 1.25 inch diameter is too big for the spindle, but it had good support. The Crawford chuck sticks out quite a way, and it read on the dial less than 1,000th, so that's good. The run out was pretty non-existent. So all I've done, just dress that off, face it off, put another chamfer on the ends, and that's it. Where the drill ejector drops in, they've got a bit gnarly, so I've dressed that with a diamond file on both sides. Yeah, I'm just running that Acme threaded section in and just check for backlash. There's a fair bit of it there, so I'm going to do a bit of adjusting. I'll make a little key for that. Right, so I've made a key there. It's about 920 across, about 120 thick. Sits nice and snug in there. Wind these down and we'll give it a tweak. What I'll do is I'll put it in the vise, nip it down with V-blocks and put a spanner across that engineer's clamp. I did the adjustments, turned it around, and basically the thread in here has been stripped out, which is why when I was adjusting it, it was no better. I then took the spindle out of the other one. Obviously it had no thrust bearings in there, it's hacky. This has got the proper thread inside, but someone's tried to do an adjustment and welded it in. So I'm going to try and I'm going to try and cut that piece out, drill out that hole and see if I can take this part out, and if it's serviceable then I'll fit it to the other one. Okay, so we've been on the lathe, dressed up this end a bit tidier, cut the welding snot out of here. Of course it penetrated quite a long way, so I'm going to do a bit more work on that. And yeah, there's a grub screw in there, and I've managed to use a reverse cutting drill at slow speed, so a left-hand drill, slow speed. It caught and wound it, so that's great. Yeah, my neighbour, who's a shed guy as well, he reckoned this was pretty much the mutt's nuts, so I'm going to give it a bit of that as well. Neither of those adjusters were easy to get out. This one, the one on the one I'm restoring, was extremely tight. You can see I've wallowed over the end of this mild steel. This one, which was in the dodgy old spindle, it was also, once you'd got the weld off, it was still tight, but it hadn't been screwed in as far. So this one came out okay-ish. I've shortened the length a little bit. The original is 850 and that's 8,450 type of thing. So I have shortened it. The grub screw sits in, or would have sat in, by about 1/2 inch. and from the grub screw to that set pin it's about 1 inch 300 thou. This adjuster piece should be 3/4 of an inch long, 750. So I've taken a chunk off the length. I'll measure the diameter here. This is the root diameter. So if you cut this at about 850 and then just did test fits, that would be fine. So 300 thousandths of land before you hit the thread. It's a 24 TPI thread, so what I would suggest, if you're making that part, turn up a test piece so you know that it threads in. I think that was so tight in this old spindle, they just didn't quite get it in. So then of course they welded it, the part's hanging out the back, so when they retract the tailstock it doesn't eject properly, so they then waller on the end of this, and then someone thinks, oh, it's not ejecting properly. If we take the bearings out of the thrust bearings out of this end, it'll get back all the way. So anyway, tragic, innit? Probably most of the abuse that this thing suffered stemmed from that original nut just being too tight. All right, so we screwed that part in nice and snug. My drive rod goes in nicely. Just comparing it to the old one, there are differences. When I say there was no bearings, it had all been shimmed out with lots of washers, and I hadn't quite picked up that that wasn't a washer, that was actually the bearing there, but you know, clearly it looked like a washer. Anyway, never mind. Okay, so in goes the screw section. There's a little bit of waggle side to side, but none fore and aft. So looking spot on. I'll put that little screw back in there. I'll put a little brass pellet in there first though. So I'm just going to line the hole, a little shim. The thread goes pretty much all the way in. Alright. So we're just in there. Snug that up. The ejector comes right into the window, so you know that's going to eject, no problems. Okay, so we're going to put the stop collar on. This one's from the newer tailstock. Previously that looks like an original finish, so there have been a few design variations, but anyway. So as soon as something measures a stupid diameter like that, it's not one thing, it's not another thing. If it's not one thing and not another thing, then I get my BA screws out, and turns out, of course, it's a 4BA. So This part's held on with 4BA screws, 4BA cap heads. So that looks like about 645, 650 long. Okay, I don't need to do this, but I do like the idea that I'll leave a piece of kit in better nick than when I found it. I was a bit surprised by it. I thought that would slide in nice and easy, but anyway, so plan B. What I'm going to do is I'm going to put the see, the key slides nice and easily in the slot there, so I'm just going to move the key into place. It just didn't want to line up nice, so the trick there is to put the key into the spindle, then put the spindle into the tailstock. Who knew? Right, that should slide in and out nice and easy on that key. We'll just check there's no wiggle on the end. Good. Right, let's flip for the tail end. This is just a gearbox oil. Just so it doesn't disappear anywhere quite as quickly. This is the ACF, slightly thinner. Okay. There's a little nick in that one, but I don't think it relates to anything inside the unit. Put the end cap on with the oilite bushing in it. Okay, so pop my cap heads in, and that end plate, that thrust plate now, back on. So we've got to put the handle back on now. Again, I'm going to put a bit of gear on here. That's the thrust bearing from this side. There's a key on the shaft. On goes the key. I'm going to put that handle back on the handle. We've got the key, goes over the key here. There's a little foot. He sits in there. A little slug pushes up again him from in here. And when that pushes up, the lock comes out. The little stubby is just over 400 thou long, about 59, 60 thou thick on the head. Diameter of the main part of the head, about 370 thou. A little spindly bit, just over 180 thou. Same diameter, and the length of this locker, the pusher, is 700. So this stalk part here is a nominal 3/16. Right, so he can go in there. Stick your finger on it. On the other side there's a spring, goes in that hole. It's a blind hole. Ball bearing sits on a spring. Alright, so there it is. There's a bit of tension on the ring. It's going to go in there, and then a node locking nut goes in from the top that's locked on, that's free to move. So the thread is 1/4 26 BSF. So that's 1/4 inch by, say, 640 about. That's one I've made up. So the head's about just over 1/4 inch depth on the head with knurlings on it. So diameter here is measuring 340 thou, measures 340 thou on my vernier. What the crikes. So 340 thou, 24 gauge thread. Righty or maddy. Well, I can't tell you what that thread is because I don't know. Got a little locker there. That's a flat bit screwdriver. A little bit too much tension there. There you go. Right, well, I've done a bit of percussion engineering on the wiper cover there, and that's good enough. So I'll put the wiper back in. Alright, so I've got 2 of these all the way in. I couldn't get them to go in properly. I've been using brand new 6BAs. So what I'm going to do is, this is a Venflon stabby needle. Sorry, I'm not robbing the robbing patience of critical equipment here. These are out of date in November, so you know they're done. Old stock. Take the cap off. Right. Oh, you can also take the brutal bit out and just leaving a nice floppy catheter in a bar as well. But anyway, so all I was doing now was just putting a bit of brake fluid through it, then a bit of air through it. It doesn't take much grit to knock out. There you go. I'll just do that top hole so you can see a bit better. I'm just going to run fluid in. There it is, and then well, there's a decent bit of puff coming through there. You know. Okay, so just putting the wiper cover back on. I haven't had to force anything. It's all been sweet. That's about a day's job. We've gone handheld. That drill's quite tight. It's a 21/64. So I've made this collar to suit each different tailstock. And there it is. No idea what it's meant to do. There we go. That comes out a bit easy. It's a bit slack in there, but it's tight in this other one, so I'll just turn that down and fit it up. Tailstock. I've got some other work to do. I'm going to replace the bearings on that tailstock, replace those damaged parts, remake the thread there. Yeah, remake that. And I'll refurbish this because I can. Anyway, for the time being, Anyway, there we go, tailstocks. Thank you very much for watching.